Alright, today's Saturday, April 12th, and this is our demonstration of our final project for graphics. And I'm going to start with a little demo. This is a short video. I don't know if you can hear the audio though. So we built a, I'll just pause it real quick. We built a traffic simulator. So the green and the blue are supposed to be the players, and they're controlled with the left and right arrows on the keyboard, or A and D. Let me just loop the file actually, and you can see the player down here. The car's crashed, and you can hear, I don't know, you might not be able to hear it, but you can hear the sound. Plays a crash sound effect when they collide. And yeah, so this is skip through this. We have 5 minutes gameplay, but I don't want to show that right now. I'll do that on our thing. Okay, let's go through the code. A lot of, you can see, wow, that's great. A lot of it's red. But what's in yellow, I will explain. So first, we're declaring the class. We're calling it Traffic Dodger 3D, or colloquially we would call it BMW Simulator. Setting the window height and title. Let's see. Server connections. This would be localhost or this IP address if we're doing it over the network. And then the port. Let's see, the matrix buffers. So we have to store the 4x4 matrices for the 3D rendering. So that's declaring the variables. Player 1's green, player 2's blue, and then declaring their positioning. So player 1 is, they have to be offset, so they're not let me pull this up. Ooh, what if I loop this file? Yeah, let me mute that real quick. So as you can see, they're offset, so they're not starting in the same position. This is kind of like a Subway Surfers demo TikTok video. Okay, obstacles in the camera, we got to set that up. So a list of float arrays, which represent the obstacles X, Y, and Z positioning. Really the only thing that's updating is the Y positioning, I think. The rendering and model variables right here. So those are for the shader program, obstacles, road geometry, stuff like that. More declaration. So the digit VAOs, these actually, so we're trying to implement a scoring system. So these are actually, this is spaghetti code. Window and networking. Identifying whether or not it's player 1 or player 2. The audio variables, talk about that. Or I won't talk about that because somebody else handled the audio. And then our main method, we're creating the instance, calling the run method, and starting the game. So you can see in our run method, we're initializing, calling the game loop, and then when we're done, we clean up. So in the init method, we set up the matrices, connect to the server, set up the window with OpenGL, load textures, shaders, models, and the audio. Somebody else will be talking about the audio. Collision detection. It's the other thing I have in my notes here. Yes, this check collisions. Okay, this is really important. So if the player collides with an obstacle, you set it to collide and then play crash sound. So it iterates through the obstacles and calculates the 2D distance using this math function between the player's x, z, and obstacles x and z coordinates. If it's less than 1, mark the player as dead, notify the server, and play the crash sound. So it's basically doing like trig, define the distance. Yeah, game loop. So we use the game loop for obstacle spawning, and it runs until the window is closed. So if you press escape, it should close. It'll spawn. It'll call process input for the handling the keyboard controls, and it'll spawn obstacles. So this is it has a 1.25% chance per frame to spawn an obstacle at random at random x, which is -3 to 3, and z, which is -25, and then notifies the server. It moves the obstacles toward the player and removes them if z is greater than 10, so that they just disappear after it's off the screen. And then it broadcasts the state. So it sends the game state to the server, clears the screen after it's rendered. It clears the screen and then checks collisions, renders the scene, and swaps buffers. And then this poll events, this GLFW poll events, is for handling GLFW events, so like a keyboard input. And then we cap the frame rate at 60. Oops. My LaTeX document didn't render that properly. At roughly 60 FPS. Let's talk about the input process. So we're just gonna kind of speed through this. So if you move left and right, your left and right arrow are for player 1, and then for player 2 you're using A and D. And if move, it constrains x to -3 and +3, so you can move across the road. Build state string constructs the string to send to the server with the game state. So the format is like state, and then player 1 xz, player 1 alive, the score, which we're not implementing, player 2, and then the obstacles as well. So there's a lot of information. I will note that our server is not really working. So in full honesty, this is again spaghetti code. But yeah, we couldn't get it working in time. Load textures. This enables 2D texturing, which is important for our asphalt. As you can see, our beautiful road here is actually a PNG. Can I show that? Can I show our assets? Is just a PNG of asphalt that I found online. And yeah, that's really what the load textures does. I mean, it's throws an exception, error handling, creating a image buffer to load it. There's the exception. Yeah. Very verbose to make sure that it works. We had some issues with the OBJ files in this, so that's what else is missing. Yeah, so that's the explanation of the code. Should we? Yeah. So we're not meeting the requirements for the object file. We had that in an early iteration, but we couldn't get it working. Multiplayer isn't working. Another requirement was like AI movement or something. I don't think we're doing that. Let me see. Yeah, so this don't have this, don't have this. Oops. got one PNG. Camera motion. Oh yeah, that's the other thing that I'm missing because it's not. We had that, and then we had to take it out for the multiplayer. And yeah, no NPCs in this game. Music. We got music, and we sort of have now working. Physics accurate motion. That's debatable. Oh, this is for the other one. All right. So that is our project.